Hi, sixth graders. Today we're going to talk about the distributive property. The distributive property is something that we're going to be using when we're simplifying algebraic expressions or numerical expressions. A great way to start to understand the distributive property is by looking at a multiplication problem and using mental math strategies. So let me show you what I'm referring to. Use the distributive property in mental math to find 8 times 53. If we were going to find 8 times 53, what we're going to do is we're going to break that down into a way that we can understand more so how to do it in our head. If I was going to ask you to do this problem in your head, some of you might be able to do this by breaking apart 50, and that's exactly what we're going to do. So if I take 8 times 53, I also, let's write it a little bit differently here. 8 times, and we know that parentheses refer to multiplication, 50 plus 3. Alright, now what we do in mental math is we would then multiply 8 times 50. 8 times 50, I'm going to write right here. And then we're going to also add 8 times 3. 8 times 50, we know is 400. How do we know that in mental math? We know 8 times 5 is 40. We add a 0 for 400. Plus 8 times 3, 24. We then have an answer of 424. Now, by doing this, you did the distributive property. You distributed 8 to 50, and you distributed 8 to 3, making this into a more manageable problem to do in your head. Let's take a look at a different type of problem doing mental math. This would be a very difficult problem to do in your head, but at the same time, if we use those principles, it becomes more manageable. So, instead of taking this mixed number and making it into an improper fraction, what we can do is we can split it apart and write it as 2 plus 3 over 4. That actually is the same thing and represents the same. Now, what I'm going to do then is I'm going to take 1/2 times 2 plus 3 over 4. Now I'm going to do the same concept of distributing the 1/2 to both. 1/2 times 2 plus 1/2 times 3/4. Now, when we multiply fractions, we simply multiply across. So this becomes 2 over 2, which is equal to 1, plus this is 3 over 8, which is still 3 over 8. That is the simplest form. Then we combine it back together to get 1 3/8. So again, maybe not a mental math problem, but definitely a different way to solve a multiplication problem dealing with fractions, especially with the mixed number. Let's look at 2 more examples and try it one more time. 5 times, break it apart, 40 plus 1. This becomes a more manageable mental math problem because now I know that I can multiply 5 times 40 plus 5 times 1. 5 times 40 is 200 plus 5. We have an answer of 205. Now, let's try this fraction one again. 2/3 times 1 plus 1/2. Again, we're going to break that mixed number apart. We can now distribute the 2/3 and multiply 2/3 times 1 plus 2/3 times 1/2. Okay, so I'm going to move over here, and now I have 2/3 times 1. If we multiply across, is simply 2/3. Anything times 1 is 1. plus 2 times 1 and 3 times 2. So 2 over 6. 2 over 6 is simplified to 1/3. Now what we're able to do is we have common denominators, so we can add. When we add these together, we get 3 over 3, which then equals 1. So a lot of work to find an answer of 1, but that is the correct answer. Okay, now let's take a look at how we can apply the distributive property to an algebraic expression with a variable. Okay, a great way to remember the distributive property is what we refer to as the Mailman Method, or depending on what season you're in, we've been referring to this as the Santa Claus Method. All right, now what does that mean? The 4 in the distributive property must be distributed to the n and to the 5. The mailman has to deliver the 4 to the n and to the 5. So if we refer to it in terms, term n must get a 4, and the term 5 must get a 4. Okay? Now, same concept as before when we were doing our mental math. 4 times n plus, let's start over here so it looks like an n. 4 times n plus 4 times 5. Now 4n, since we don't know what n is, it just simply remains 4n. And then 4 times 5 is 20. All right. And that is how we simplified the expression. We cannot simplify anymore because these terms, 4n and 20, are not like terms. Moving on to the next problem, we're going to do the same concept. We're going to deliver the 12. Again, in this concept, now let me just erase this here real quick just to give a little more space. Okay, so again, we're going to deliver the 12 to 2y and the 12 to 3. Okay, now 12 times 2 is 24. We have to keep the y doesn't change, so 24y minus 12 times 3 is 36. Okay? Now also this can be referred to as the rainbow method. Oftentimes the rainbow method can be a good way for you to remember because we're creating a rainbow every time that we deliver that. Okay? Alright, let's take a look at one more problem. Okay, I'm just creating some space here. Now, when we have 3 terms within the parentheses and we're multiplying, I guess the rainbow method is a good way to think about it because now we're going to be creating 3 arcs here. We have to deliver the 9 to the 6 to the x and to the 2. Okay, so 9 times 6 plus 9 times x plus 9 times 2. Okay, I'm going to move up here for some more space. So 9 times 6 is 54 plus 9 times x is simply 9x plus 18. Now, as I mentioned before, when we have like terms, now I mentioned I'm going to go back and fill these back in. Okay, these terms are not alike. They're not the same. One term is a constant without a variable, and the other term has a variable, so we can't combine those together. Same with this answer previously, 24y minus 36. Again, same thing. These terms, this expression does not have terms that are like, so we can't combine that, so we're done with that problem. Now this problem, we have 2 constants, 54 and 18. There is no variable. Since this is all addition, we can combine those 2 terms together to make a simpler expression. Okay? So, when we combine these 2 terms together, we get 72. 54 plus 18 is 72 plus 9x. We can't touch the 9x. simply because it has a variable and is not a like term with the 72. So 6th graders, I hope that helped with the distributive property. And then at the end there, a quick introduction to simplifying like terms using the distributive property. Thanks.